Another example of a tensor in physics is the inertia tensor. Let's consider the angular momentum. So the angular momentum is m, the mass, times r, the distance, cross product with the velocity. And the torque that is produced on an object is tau, is the cross product between the distance and the force applied. We can also specify this relation in terms of the inertia moment. We can define the angular momentum as the moment of inertia times the angular velocity. And this leads to the following equations for rotational kinematics for the relationships between torque and angular momentum. The torque is the time derivative of the angular momentum, and the angular momentum is the inertia moment times the angular velocity. These are rotational analogs of the linear relations between force and momentum. The force is the time derivative of the momentum, and the momentum is the mass times the velocity. You substitute linear momentum by angular momentum, force by the torque, the linear velocity by the angular velocity, and what plays the role of mass for the linear momentum is the moment of inertia when it comes to the angular momentum. Now for the forces, F is equal to ma, and since mass is a scalar, then the force and the acceleration are always in the same direction. The same is not true for rotation. For rotation, we have that the torque is equal to the moment of inertia times an angular acceleration, and the torque produces an angular acceleration. So for rotation, the torque is equal to the moment of inertia times the angular acceleration, where the angular acceleration is a time derivative of the angular velocity. The angular acceleration produced is not necessarily in the same direction as the applied torque. Indeed, depending on the mass distribution, a torque applied, say, in the z direction can produce rotation around any of the axes. A scalar would produce acceleration in the same direction as a torque. That's what happens for the force and the linear acceleration. Thus, the moment of inertia is not a scalar, unlike the mass.